Hello and welcome to this solution video, and thank you for clicking on that thumbnail. This video is the edited version of my last year's video of 7 questions, 7 separate videos on which I got single digit views. These videos were prepared one day immediately after people wrote the exam, but since the number of subscribers were very low, so the views are very less, so I combined them to make one video now. And two of the questions, the quality was very poor, so I re-recorded them and edited into this video. I hope you will like this. If you do, please click that thumbs up icon and subscribe to my channel. Thank you very much. In this question, the mass of 0.6 kg is being projected downwards. That means it is being given a very hard push at 4 meters per second. Okay. Now, they are asking us to use energy method to find the speed of the particle after 15 meters. Let's assume that 15 meters is the whole length of this slope. So up to here, this level is 15 meters. So for energy method, we have this formula: change in kinetic energy plus change in potential energy is equal to the work done by the applied force minus work done by resistance. Since they are saying it's a smooth plane, so there is no resistance. Since it was projected and nothing else was pushing it down after that, so there is no applied force also. Right. Some of you may think that there is a natural force mg sine theta in this direction that is being applied continuously. But don't worry, that will be taken care by potential energy. It is nothing but the work done by gravity. So we will ignore that force. Right. So let's write the formula for difference in kinetic energy. Half m final velocity square minus initial velocity square plus difference in potential energy will be mg final height minus initial height and equal to 0. Why? Because there is nothing on the right side. Okay, let's substitute the values. Half mass is 0.6. Final velocity we have to find out. U we know is 4 square plus mass G is 10. H2. Okay, H2 we know it reached ground, so 0. H1. Okay, the original height was H1. Let's try to find it out. We know this is 10 degrees. And this is 15 meters. So we can find H1 over 15 equal to sine 10 degrees. Opposite over hypotenuse, right? So H1 becomes 15 sine 10 degrees. Alright, so we'll write here 15 sine 10 degrees equal to 0. Okay, 2 and 0.3 cancel, sorry, 0.6 cancel, it gives us 0.3. So if we expand, it becomes 0.3 v squared minus 16 times 0.3, 4.8. 6 times minus 15 minus 90 sine 10 degrees. 0.3 v square stays here. 4.8 plus 90 sine 10 degrees goes to the right side. So v square becomes 4.8 plus 90 sine 10 degrees over 0.3. And we can square root both sides to get v. So using the calculator, v comes out to be 8.25 meters per second. In this question number 2, these 3 forces have been given to us. They are coplanar, and angles are also given theta and alpha, so that sine alpha is 5/13 and sine theta is 8/17. So since they are not in equilibrium, we cannot use Lami's theorem. So we have to find resultant, its magnitude and its direction. Right? So first what we will do, we will resolve all these three forces into their components. So since this one is horizontal force, so there is no need to resolve it into component. It is itself a component. Alright, so let's talk about this one, 26 Newton. Since alpha angle is here, this will be 26 cos alpha. And the horizontal component will be 26 sine alpha. Alright, now 34 Newton force. This component will be 34 cos theta. And this one will be 34 sine theta. So now we clearly see that the horizontal forces are 30 newtons to the right and these two forces to the left. So let's find the resultant in horizontal direction. It will be the difference of these two. Since there are two forces on the left side, I will take that as positive. So let's take 34 sine theta plus 26 sine alpha as positive and 30 as negative because it is to the right. And let's replace their value. It will be 34 sine theta is 8 over 17 plus 26 sine alpha is 5 over 13 minus 30. 17 and 34 cancel, 13 and 26 cancel, so it becomes 16 plus 10 minus 30. So that comes out to be minus 4 Newton. That means these two forces together, these two components together are still less than 30. And that means the resultant will be in right direction. This is very important to notice. Let's talk about the vertical components. So resultant in vertical direction will be 34 cos theta, 34 cos theta minus 26 cos alpha. And these are two forces in vertical direction, and I'm assuming that this is more. For that, we need to know cos theta and cos alpha first. So let's find cos theta and cos alpha through a triangle, because we know sine alpha is 5 or 13. That means if this is alpha, sine theta is opposite 5 and hypotenuse 13. And if I use Pythagorean theorem, definitely this side is going to be 12. So cos alpha will be adjacent 12 over hypotenuse 13. So we got cos alpha. Similarly, we'll find sine theta, cos theta rather. Let's say this is theta. And sine theta is opposite 8 over hypotenuse 17. Okay, this is opposite over hypotenuse. And if I use Pythagorean theorem again, so 289 minus 64, that is 225, so square root of 225 is 15, will be this side. So cos theta comes out to be 15 over 70. And let's put them here. So RB, vertical resultant force, will be 34 cos theta. Cos theta is 15 over 70 minus 26 cos alpha is 12 over 13. So 17 and 34 again cancel out, 13 and 26 cancel out. It comes out to be 30 minus 24, which is 6 Newton. So now we have vertical component of the resultant and horizontal component. So let's do it. What did I think as positive here? It was upwards. Okay, so this resultant is upward because it's positive. So first let's draw this vertical only, 6 newtons. And from the head of this we'll draw 4 newton to the right. So 4 newtons. And this will be the final resultant. Let me give it a different color. This is the resultant. We want its magnitude and direction. Magnitude is easy, so let's call it resultant. So resultant magnitude will be, we'll use Pythagorean theorem, 6 square plus 4 square, which is 36 plus 16 square root of 2. We need direction as well. So we will find the direction from the tail. We always find the angle at the tail, that gives us the direction. So this is the angle we'll find, and we can't use theta, sorry. Let's use some other alphabet. Let's say A. So tan A will be opposite, which is 4 Newton. Resistance is 6 Newton. So A is tan inverse 4/6, which is 2/3 basically. So let's see what acute angle it gives us. A becomes, it is 33.7 degrees, and that will be 33.7, but we need a reference, and we know this 30 Newton is towards right, so let's take this as reference. So we'll draw a line here, and let's say what is this angle outside. Angle is 90 minus 33.7, which will be 56.3 degrees, right? So we can write the final answer. Resultant force is square root 52 newtons, 56.3 degrees above 30 Newton force. That's the reference, because this is what we are sure about. Here in this question, they're saying there is a rod. So let's draw a rod. Alright, and there is a ring on this rod, which is threaded. Threaded means it goes over the rod. Ring over the rod, okay. Alright, and this ring's mass is 0.3 kg. That means there will be a weight of 3 newtons downwards. Yeah? It is being pulled by a force of 8 newtons, which is 10 degrees above the rod. Okay? Now they're asking, find the time taken for the ring to move from rest to 0.6 meters along the road. Okay. So we know S is equal to UT plus half AT squared. So this is basically we need 0.6 meters is the distance, U is 0, time unknown, that's we have to find out, plus half acceleration we don't know, and T squared. That means acceleration is the only one that is needed so that we can find out how much time it will take. So for acceleration we should take care of the forces on this ring. So we know X component of 8 newtons will be 8 cos 10 degrees, okay, and the Y component will be 8 sine 10 degrees. Angle is here, so this will be cos, okay. Besides this, there will be a reaction force upwards by the ring, okay, against its weight. So we know according to Newton's second law that net force is mass times acceleration, and net force will be the force which is driving it, which is this one, 8 cos 10 degrees, against the force which is trying to stop it, which is frictional force here. So frictional force. Alright, but for frictional force we know that frictional force is mu r. Yeah, so we'll write 8 cos 10 degrees minus 0.8 R. So there is another problem where we have to find R now, and R will be found by the vertical forces. So we know the vertical forces are R and 8 sine 10 upwards and 3 newtons downwards. And since this ring is not going up or down, they are equal. That's why I have equated them. So R becomes 3 minus 8 sine 10 degrees, and this is what I will use in place of this R now. So our MA becomes 8 cos 10 minus 0.8, 3 minus 8 sine 10 degrees. Okay, so acceleration will be 8 cos 10 minus 0.8, 3 minus 8 sine 10 degrees divided by M. M is mass 0.3. Alright, so acceleration it gives me is 21.96 meters per second square. This is the acceleration we will use in our equation here. 0.6 equal to half 21.96 e squared. So cross multiply 2 here, 1.2, and this divides 21.96 equal to t squared. So t becomes square root 1.2 over 21.96. And let's see how much it is. It's 0.23 seconds.
Question 4. A particle of mass 12 kg is stationary on a rough plane. So this is a rough inclined plane and 12 kg mass is on it. So its weight downwards will be 10 times 12, which is 120 newtons. Okay. It is inclined at 25 degrees, so this angle is 25 degrees to the horizontal. A pulling force of P newtons acts at an angle 8 degrees above a line of greater slope on the plane. This is called line of greater slope, this one. So 8 degrees above this. So this is much more than 8 degrees, but for clarity, I am writing it 8 degrees here. So this is P. Okay. This force is used to keep the particle in equilibrium. Okay. So that means this particle will not slide down. What will make it slide down? Its component in downwards direction, which is 120 sine 25. It is always sine component of 120. Why? You can watch my some previous videos for this. All right. Coefficient of friction between the particle and the plane is 0.3. All right. Find the greatest possible value of P. Greatest possible. When is it greatest possible? When friction also joins this force, so that you have to apply more force. Friction plus this, right? It is least when friction joins P and both of them stop it from sliding down. Then it becomes least. But we are saying greatest, that means friction will be downwards. So since it is in equilibrium, that means the component of P in this direction, which is P cos 8 degrees. This P cos 8 degrees will be equal to these two forces, then only it will be in equilibrium. So let me write the initial equation. It will be F frictional force plus 120 sine 25 equal to P cos 8. Simple. Okay. But P is unknown. Right now F is also unknown. So we know that F is mu times reaction force R. So let's see where is R. R is in this direction. Yes. But R is not the only component of force. There will be another component. P cos 8 is the component of P in this direction. There will be another component in this direction, which will be sine component. So wherever we have angle, that becomes cos component of the force, and on the opposite side of the force, it's sine. These two will be equal to the weight component in this direction, which will be 120 cos 25. And this is going to give us the value of R. Yeah, R is unknown in this direction. Both of them are known. Rather, it's in terms of P, but still it is okay. So I will make an equation here now. P sine 8 degrees plus R is equal to 120 cos 25 degrees. So let me isolate R here so that this is in terms of P. 120 cos 25. This is 120 cos 25 minus P sine 8 degrees. 120 in cos 25, we can evaluate this. So R becomes 120 cos 25 will be 108.8 newtons minus P sine 8. Rather, sine 8 also I can evaluate. Sine 8 degrees is 0.14 and P is P. This is the R we are going to use here. So it becomes what? F equal to 0.3 times R. We just got it. 108.8 minus 0.14 P. Okay. So what we can do, we can write in place of this F, we can write this now. So 0.3 times 108.8 minus 0.14 P. Now after that 120 sine 25, I can evaluate this also. It comes out to be 50.7 newtons equal to P cos 8. Our target is to find the value of P. That means this P and this P must combine. For that I'll have to open this bracket. So 0.3 times 108.8 will be 52.64. No, 32.64. 32.64 minus 0.4 times will be 0.042p plus 50.7 equal to P cos 8. Cos 8 can also be evaluated. It will be about 0.99. There's some digits. I'm rounding them off so that I will get closest possible answer. So this P and this P, I can bring it to the other side. So let me put it here. 0.99p is already here. I will add 0.042p here. Okay, what are we left with here? 81 point something, 83.3, 32, and yes, 83.34. So 83.34 newtons is equal to 1.032 P. Divide both sides by 1.032. 1.032. We get P equal to 80.8 newtons. That is the greatest value of P, which will keep the system in equilibrium.
In this question number 5, this is the situation. A car of 1250 kg is pulling a caravan of 800 kgs. These are two forces of resistance on each one of them, and it is moving at a constant speed. This is the key here. Constant speed of 30 meters per second. Constant speed means whatever is the resistance, same is the effort by the engine. Okay. First part says calculate in kilowatts the power developed by the engine. So power always belongs to engine, and it always equal to the applied force by the engine multiplied by the speed. So first we need to know applied force, and we already know that applied force by engine is same as the resistance. and that comes out to be 720 newtons. Yeah, so power will be 720 newtons multiplied by speed, and that has to be 21600 watt. They're saying in kilowatt. So kilowatt it will be 21.6 kilowatt. Okay, in second part they're saying that this power is suddenly decreased by 8 kilowatts. So it was 21.6 kilowatt. It is subtracted by 8 and we are left with 13.6 kilowatts only. Alright, so now we need to know the force. So we will convert this to 13,600 watts first. Okay, and then we know that power again is F force times speed. So force becomes power over speed. Power is 13,600 divided by speed is 30 at that instant, because they're saying instantaneous, right? So gone. So let's leave it 1360 divided by 3. That is the power. Now we know that there is already 440 and 280, 720 in one direction. So let's say what is the new acceleration? So it will be force forward is 1360 over 3 minus 720. So the mass of two parts is 1250 plus 800 kg. Times acceleration equal to, it will be 1360 minus 2160 over 3. So it will be 2050 A equal to minus 800 over 3. So acceleration will be negative 800 over 3 times 2050. That is minus 0.13 meters per second square. Second part, they're asking what is the tension between the bar between the car and the caravan. Okay, this bar. So if we take only this one, only this part, so what will be the free body diagram? There is tension in this direction. There is a resistance of 280 newtons in this direction. And we know what is the resultant. So resultant F net equal to MA equal to T minus 280 newtons. Okay, so the mass of the caravan is 800 kilograms. Acceleration we just found out 0.13, which is actually deceleration. T minus 280. So P the tension here, and 800 times 0 minus 0.4 plus 280. So tension comes out to be 176 newtons. This is the answer.
Question number 6, and I got a lot of requests from my students and subscribers to solve this question as well. So I solved it, but the quality was not good. So I'm re-recording this one. A particle A is projected vertically upwards from level ground with initial velocity 30 meters per second. Okay, so it was projected upwards, and U is particle A, right? So UA is equal to 30 meters per second upwards. Okay, at the same time, at the same instant, particle B is released from rest. So it is released from rest. UB equal to 0 meters per second. This is particle B here. Alright. 15 meters vertically above A. So the distance between them, this distance is 15 meters. Okay. The mass of one of the particle is twice the mass of the other particle. So they have not specified which one is heavier. So we can say that MA equal to 2MV or MB equal to 2MA. We are not sure. Okay, let's make them two situations. All right. During the subsequent motion A and B collide, they collide somewhere here. Okay. And coalesce. They become one body after collision. Okay, so momentum is part of it. Find the difference between the two possible times at which C hits the ground. They become C after adding to each other. That means there will be a time A here and time, let's say time 2 and time 1, not A and B. Time 1 here, time 2 here. We have to find the difference between these two times. Okay. First thing, we should understand very clearly that mass has no role in motion. If you look at your kinematic equations, mass is never mentioned. That means no matter which one is heavier or lighter, they will collide at the same height after same time. Let's find that same height and same time first. Okay, so we know that S is u t plus half at square, right? So let's say they are colliding here, so we will assume that the distance from B to X, B to this collision point is X, okay? And then distance from A till that colliding point will be 15 minus X, because total distance is 15, this will be X, this will be 15 minus X. So let's make an equation for B first, okay? So S, distance is X for B, U, it is being dropped from rest, so 0 plus half. Since this situation is quite complex, let's make one rule, that everything that is downwards is positive. So the G here, acceleration is downwards, so we will take it as positive 10 and t square. So X becomes 2 and 10 cancel, 5 t square. Let's make a similar equation for B, not B, A. So in this case, the distance is 15 minus X, but this 15 minus X is upwards, and I said to simplify every complex situation, downwards is positive. That means I will write minus 15 minus X in this case because it is going upwards, equal to initial velocity U for A is 30 meters per second, again upwards, so minus 30 t, right? Plus half, A will always be downwards. A will never change its direction, it's natural thing. So 10 and t square. So what it gives us, minus 15 plus X equal to minus 30t plus 5t square, right? X is 5t square, same time, because they are taking exactly same time to collide. So we can replace this X here. So minus 15 plus 5t square equal to minus 30t plus 5t square. Both are plus 5t square on both sides. That means if I subtract 5t square from both, they get cancelled out. And then we are left with minus 15 equal to minus 30t divided by minus 30 here and minus 30 here. 30 cancel, they become, so t equal to 1 over 2 seconds, half seconds, and it does not matter what is the mass, which is heavier, which is lost. I'm again saying because mass has no role in these cases, kinematic equations. All right. Now, let's find the X now. So I can use this equation for X. So X is equal to 5 times half square. Yeah, 5t square was the equation, and it becomes 5 times 1/4, which is 1.25 meters only. So that means this is 1.25 meters below from where B was released, and 15 minus 1.25 will be 13.75. So this distance is 13.75. Okay, the point above A is 13.75, below B 1.25, total 15 meters. All right. Find the difference between the two possible times at which C hits the ground. All right. Now they collide and become one point C. Right. Now C will either go up after collision and fall down, right? Or it will straight away collide and they will start go down and hit the ground. We don't know whether it's going up or down after collision, right? For that, we have to find the v of velocity of C, and that will be used by using conservation of momentum. Since we have two situations, either this or this, that will give us two velocities, and that's why we have to treat them separately. So what is our formula? Formula is this: m1 u1 plus m2 u2 equal to m1 plus m2. Because they coalesce, they become one bodies. This is the formula we will use. So here we are saying that ma is twice mb. So let me write ma first. And what is the velocity of u1 when they hit? We don't know. So another layer is here that we have to find the velocity at which these two particles are colliding. So let's find their velocities before collision. Please, these 0 and 30 are not before collision. We need to know how much is the velocity when they reach at the point of collision. So for that we'll use this v equal to u plus 80. Now v equal to, for let's do for b first again, right? U is 0 and a acceleration is downwards, time is half, we know now. So it is 5 meters per second, v of b. Let's talk about v of a. U is upwards, so minus 30. Yeah, it is upwards. Plus 10 and time is half. So it becomes how much? Minus 30 plus 5, minus 25 meters per second. So they are in opposite direction. That gives us the velocity now. So ma and the speed of a is minus 25 meters per second. So we'll write minus 25. mb u2, the velocity we got was positive 5 meters per second. m1 plus m2 and v we want to find out later. All right. So ma is 2 times mb. So ma 2 times mb times negative 25 plus mb times 5 equal to, okay, m1 plus m2 will be ma plus 2 mb plus mb will be 3 mb. Yes or no? v. So this is ma, this will be mb, and ma becomes 2 mb. So 2 mb plus mb is 3 mb. All right. So all of them have mb. Let's divide by mb the whole equation, so that we get rid of the mass which is not important. So 2 times minus 25 is minus 50 plus 5 equal to 3v. That becomes minus 45 equal to 3v, divide by 3 here, divide by 3 here, which will be v equal to negative 15 meters per second. That means it is upwards, because downwards we took as positive, right? Let's do the same thing here. In this case, mb is 2ma. So I will substitute this mb, but everything else will remain same. So ma times minus 25 plus 2ma times 5 plus 3ma, sorry, not plus, equal to 3ma times v. Okay, again we divide by ma, so ma goes from all these three, so minus 25 plus 10 equal to 3v, minus 15 equal to 3v divided by 3 both sides. V is minus 5 meter per second. Again, it is going up but slower when MB is heavier. All right, these are the ones. Now our aim was to find T1 and T2, to find the situation, what is the time taken by this. So now let me redraw this situation. The point of collision is 13.75 meters above ground, right? Both are going up after collision. After they become one body, they both are going up. That means the situation I drew earlier is true, and then they will fall down on the ground, right? So what will be the displacement? This is the starting point of after collision, this is the end point, so this will be the displacement, right? And we will use again the same formula for displacement, this one. So again we will use the same, this situation first for T1. My aim is to find T1, okay? So S 13.75 downwards positive, yeah, because we said that downwards is everything downwards is positive, equal to UT. Now U is upwards, minus 15T plus half A is again downwards, 10T square. So what do we get here? 13.75 equal to minus 15T plus 5T square. Let's do what? Let's make a quadratic equation out of this by bringing this 13.75 also to the right side. So 0 equal to 5T square minus 15T minus 13.75. Okay, so will be, let me use my calculator straight away. We can use quadratic formula, or otherwise here we can find the time. By the time I use my calculator, I will request you to like this video by clicking on the thumbs up and subscribe to my channel. I'll be making many more videos like this for you in future too. So what I'm getting here is T equal to, I'm taking the positive one also only because there will be a negative also, 736. This is the time 1. Same thing I will do here. 13.75 equal to minus 5 this time. Yes, the velocity upwards is 5T plus 5T square. So the equation, quadratic equation becomes 5T square minus 5T minus 13.75, and it gives me T positive time is 2.232. This is T2. All right. And if we go back to the question, it shows find the difference between the two possible times. These are the two possible times. We have to find the difference between them. So difference between two possible times is 3.736 minus 2.232, which will be 1.504, and 3 significant figures will be 1.50 seconds. That's the final answer.
In this question number 7, they're talking about a particle that is moving in a straight line and its acceleration changes. In the first 2 seconds, the acceleration has dissipation, then it is a constant for next 2 seconds, and next 12 seconds, this is the equation. So they are asking us the time when the velocity is 55 meters per second. But we are not sure. It is starting from rest, but which of these 3 parts will give us a 55 meter per second velocity, we are not sure about it. So we'll have to try it for every one. So for finding velocity from acceleration, we should integrate the equation of acceleration. So 6 plus 4t is the first part, and we'll integrate this one. It comes out to be 6t plus 4t square over 2 plus c. And this is velocity. Yeah, we know it starts from rest. So when t is 0, v is 0. So to find c, we can use it here. So if we substitute here, velocity is 0, 6 times 0 plus 4t square, sorry, 0 square over 2 plus c. C, everything is 0, so c is 0. So the equation of velocity becomes 6t, that is this one we will write, right? 6t plus 4 and 2 and 4 cancel, 2t square and c is 0. So this is the equation. Okay, since this is a quadratic equation, let's find what is the speed after 2 seconds. So 6 times 2 plus 2 square, that becomes 6 times 2 is 12 and this is 8, 20 meters per second. So it started from rest and ended at 20 meters per second, but the equation of velocity is a quadratic equation. That means it may have turned in between. It's possible. Let's see if we got 55 meters per second anywhere in between. So 2t square plus 6t equal to 55. 2t square plus 6t minus 55 equal to 0. And let's see what times it gives us. 3.95 and minus 6.9. Negative time is not possible and 3.95 is out of this time. That means both the answers are not acceptable. So we have to proceed to the next one. The next part, the acceleration is constant, 14. Since it is constant, we can use kinematic equation. So let's see what is v. v equal to u plus at. So v equal to u, when 2 seconds ended, we were having 20 meters per second. So that was the u for next 2 seconds. And acceleration is given 14 and time is, during that time is 2 seconds only. So let's see what is it. For 20 plus 28, that becomes 48 meters per second. And since it is a uniform acceleration, we can't have a speed of 55 meters per second in between. So this is also gone. So third part is the only one left now. For that, we have to again integrate the third part. Third part is 16 minus 2t. Alright, so it gives me 16t minus 2t square over 2 plus c. So 2 and 2 cancel, 16 minus t. Okay, let's say what is the value of c. So we can take this value. At 4 seconds, 48 meters per second was the speed when it started. So we will write 48 meters per second is 16 times and 4 was the time minus 2 and 2 had already cancelled, 4 square and plus c. Okay, so it becomes 16 and this is 64. So 48 equal to 48 plus c. Again, c comes out to be 0. Alright, so our equation for the final part, it remains to be v equal to 16t minus t square. Okay, there's now some space, so 16t minus t square equal to 55. That's our requirement in third part. So let's bring everything towards one side. So t square minus 16t plus 55 equal to 0. And if we use our calculator, the times we get are t equal to 5 and 11, and both are in our range of 4 to 16 seconds.